I've been practicing this. So, minasan, konnichiwa. Weldon to moshimasu. Kyo wa jikan itadaki arigatou gozaimasu. See, I've just been to Japan, and I spent a lot of time learning that introduction, and so damned if I'm not going to use it in every meeting that I can. Maybe it's not appropriate for Brighton, but here we go. Just before that, I spent some time in Australia, and I'd use an Australian greeting, but I don't think it's appropriate in a work conference to use that much cursing. So we'll just keep it simple. My name's Weldon Dodd. I'm very pleased to be here again in Brighton at MacAd. Thanks to Jigsaw for putting on such a great event and for allowing us to come and participate. We're very happy to sponsor again because we love being around other Apple admins and people that do what we do. And the energy from being in the same room and having conversations with folks that are interested in the same things and are pursuing the same goals that we are, frankly, is invigorating and exhilarating and something that I look forward to wherever I go in the world. So myself, I am one of the leaders at Kandji. I joined about the seed round, and so I spent the last 4 years building several different teams at Kandji, and currently act as the SVP of Global Solutions, which means I lead our technical resources on pre- and post-sales. I get to do conferences like this, and I don't know, I try to find ways to be useful. My colleague Noah Anderson, unfortunately, could not be with us, but he gets most of the credit for the technical content in this presentation. Noah is a lot smarter than I am and has built some really cool stuff that I get to share with you, but I don't want you to be confused and think that I had anything to do with it, right? Noah is the one who has done all the hard work here. So the topic for today is automation. Now, automation is something that's been really important to me for a long time. I started my career as a Mac admin 30 years ago. I ran a Mac lab and a Next lab at the University of California. Automation in those days meant I walked around with a 400K floppy disk that had all the tools and files and settings and things I needed on it, and I would pop it into a Mac and copy them over, and then walk down to the next one, pop that disk in, wait an incredibly long time, and then touch the keyboard and the mouse in order to set it up. Now, eventually I got some tools that would allow me to touch the keyboard and the mouse from my desk, Timbuktu, things like that, right? That was incredible. Now I didn't have to walk around quite as much. Eventually we got tools that allowed us to transfer files over the network, so I didn't even have to have the floppy disk anymore, right? OS 10, we got ARD and some of those things, and remote shell scripting. And maybe 20 years ago, we started to get tools that allowed us to assemble those steps, the things that I did by touching the keyboard and the mouse, and automate them, right? And that approach has been really useful for a long time. The ability to program a tool that's going to do the things that I would do if I was sitting in front of the computer. Do it in a repeatable, reliable way. That approach, though, is inherently imperative, right? You have to know the steps. You have to know the sequence to assemble the steps. What are the knobs and buttons to move? What are the switches to flip? You've got to put them in the right order. If something goes wrong, you need to anticipate what to check for to understand what went wrong, and then maybe build a different sequence to correct that, right? So it has been a lot of work, but the tools have gotten better and better over time. Part of my experience was doing professional services work with Apple, with some others around the industry. And as part of that, I had a really incredible opportunity to work with some of the largest Apple deployments in the world. I worked with one of the largest private equity firms in the world with hundreds of thousands of devices. One of the largest retailers in the world with over 100,000 devices, and many other large customers. And it was interesting to me that as I went through all those customers, oftentimes I would find that I was doing the exact same things for every single customer. As we helped them implement their tool set and the platforms that they were going to use to manage their devices, I would bring my little bag of tricks, the set of scripts, the tools that we all shared around and traded with each other, and I would implement the exact same things for every single customer. And at some point, it raised the question, if I'm doing the same thing every time for every customer, why doesn't the tool just do that for me? And that was the spirit that we brought to Kandji when we started to build a brand new management platform for Apple. How can we automate some of these tasks and make them easier? So before I get into AutoPkg and some of the CI/CD stuff that I promised to tell you about, I just want to hit a couple examples. So device name. I added this one just for Armin, okay? So sure, we can have a library item here where you can drag in some components, the asset tag, put in a separator, and then the username, Armin, just for you, right? PII here. But you can see the pattern that's being used to assign the device name. So this is a more declarative approach, right? This is how I want the device name to be done. This is the pattern that I want implemented. You'll notice the icons above. This is done for the Mac, as Armin so beautifully explained earlier today, right? That's done through scripts or the command line, but we also have iOS, iPad OS, Apple TV up here as well. Those devices are named by MDM command. So what's useful here is that you can set the pattern that you want the devices to be named. We do it one way on the Mac with our agent using the command line tools and those APIs. And for iPhone, iPad, Apple TV, we use the MDM command, right? So if Apple changes the way this is done in the future, right, we don't anticipate that our approach will change. You just set how you want the device name to be. We'll figure out the path to get there and set that correctly. Home screen layout's another good example. So, oftentimes tools will present a list of apps to be installed, and you can drag and drop that list to get them into the right order, but it's been difficult to see what that looks like. So what we've done here with the home screen layout library item is that you can visually see what's going to happen with your layout. You can drag items over. So if we're a Microsoft shop, put OneDrive in there. We could put Outlook in the dock. We could put Teams in the dock. And then the other productivity applications, PowerPoint, Excel, Word, et cetera, and arrange them in the order that we want. Let's add Okta Verify in there. Maybe use Jump Cloud or something else. You could put those apps on the screen and see how it's going to look. Now, this saves you a lot of time, right? If you've built that list, if you want to see it, you've got to push it to a device, wait for that to happen. If you make a change, push it again, wait for it to show up on device. This saves time, just a more direct approach to configuring those options. Last one here, File Vault. This is old news, right? We've all done disk encryption for a long time. But if you've been around a while, you've seen it change over the last 6-8 years. We've had a couple different ways to enforce disk encryption, and we've seen the key escrow process change across macOS versions. So with our library item, there's just a checkbox to enforce encryption. There's another one if you want to make sure it's done at enrollment. There's needs to have disk encryption in place before you put sensitive assets on the device, certificates and so on. And then for the recovery keys, if you want to escrow them in Kandji, you just check the box. We automatically detect, is the key already escrowed? If it's not, we prompt the device, or we ask the device to regenerate a new key so that we can protect it and send it back to Kandji. If that requires the user to sign in as part of regenerating a new key, we do that automatically and create a nice little user experience through our menu bar item to prompt them to do it. If we can do it automatically at the login window, we'll do that. Okay, so again, you just check a box. I want it to be encrypted. I want the key to be escrowed. We take care of the rest. Okay. One little, last kind of fun feature there is this option to automatically rotate the keys. just check the box, move the slider to how many days you want, and the keys will be automatically rotated as you like. So this focus on automation has been really important to us for a long time. But we've been able to do some interesting things this year with continuous integration and continuous deployment, or continuous delivery, right? I've heard it both ways. I don't really have a preference. But CI/CD workflow. And the goal here is that if you make a change in a managed repository, you want that change to go through your review process, an approval process, and then to get pushed into production, right? And so our APIs and some tools that we built allow us to do that. So the first example I want to show is GitHub Actions. And so, it doesn't have to be GitHub, but I think it's illustrative of the kind of thing that people would want to do with whatever tool they're using. GitHub, GitLab, Workato, some platform like that. There's really three things to think about here. So one is, what is the trigger? What is going to kick this off? In the example I'll show, there's a very clear trigger. What action is going to happen? What does that process look like? What are the steps that are involved? And then the last step is we're going to use the API in order to push that change into the platform, Kandji in this example. So I'm going to do a live demo, and let's hope it all works. Okay? So I've got a script in. Can we get this on screen? I suppose I'll have to switch to mirroring. Give me a moment. So it's quite nice to have it not mirrored when I was running Keynote, but we'll flip it this way for now. Okay, so I've got this script set up in Kandji. We're looking at it in my instance. And if I scroll down, you can see some metadata about the script. It's available in self-service. It's in a category called scripts. It's marked recommended. And then here's the script itself. Last update by Weldon at 1:22 p.m. Okay. This script is actually managed in a repository. So let me open up GitHub Desktop, and I've got an uncommitted change here. Let's get, wow. I'll just audible here into Visual Studio Code. It'll be a little more clear. But here's my script. Let's change this time here. So what is it now? 4:14 or so. It's PM. We'll save this. And now that I've made this change, very simple, obviously, but I've got a new commit to make. So we'll do that. And I've made this commit in Git. And now I'm going to sync that change up to my GitHub repo. So if we take a look here, this is where it lives. And in the Actions tab, right, what we'll see is that when this was still spinning, wasn't it? Let me make sure it triggered. It's just a problem with doing demos, isn't it? Yeah, an hour ago. All right, let's do it here. This will work as well. Okay, so 4:15. Okay. And now I could follow the review and approval process that I have set up in this repo if I wanted to. This one has main branch protection, requires multiple approvers, all of that. So if you want that as part of your flow, you can build that in. I'm going to skip all that, right, and just commit directly to main, as one does. And now if we go back and look at the actions, we see that this action has been triggered successfully now that we've pushed the change up. And so what's happening here is an action is running because of this commit to the repo. It's going to follow a set of instructions. It's completed successfully here. So if we go back to Kandji and refresh this page so we can see the updated script, okay, sure enough, last update now 4:15 p.m. So you can imagine what that would be like if there was a more substantial change. But let's take a look at how this works. In the repo, here's the folder check folder with that shell file. Okay, there is a JSON file next to it. And this file, I'll zoom in, contains the metadata associated with this script. So its name, it's being delivered through self-service. It does not require a restart. It's in self-service, et cetera. It is recommended. All of those details are in this JSON. That's where we're storing the metadata. Now, the other piece of this is in this workflows folder is where the action and what happens is all defined. So in the kandji.yaml file, the name of this action is change files. It gets triggered on a push or a pull request to the main branch. So this is the trigger. And once that fires off, it goes through this job, which starts a runner on Ubuntu in GitHub's environment. And it does a few things. It does a checkout of the repo to find out which files have changed. It runs it through this action here, which was provided by the community. And it generates a list of changed files, but it filters it down to any .sh or .zshell files. That list of files then goes through these steps here. So for each changed file, it has to be a .sh or a .zsh file. If the file was changed, we get its ID from the JSON that has the same name, same file name, different extension. We pull the JSON data out of it. We cap the script, and then use the printf with these options here to escape all the special characters. So when we're submitting it through the API request, we don't run into any issues with special characters. And we build the JSON with the script itself and the associated metadata. That becomes our payload. That payload is then used in this curl command, which calls the API. The base URL for my Kandji instance is defined in an environment variable, which is shown here, vars.baseURL, the API endpoint that we're calling, and then the authorization is this bearer token, and the API token is stored again in an environment variable in this secrets system that GitHub provides. So what's nice about this is that anyone who can read the repository, so if we go in here and look again at the files that are in this repo, the secret's not anywhere. You can't read the token, you can't get to it. Only the admins who have access to the environment variables or the secret store can see that. So other people can make commits and changes to this repo without necessarily having to have access to the secrets. All right. So there's one example of how we can do this. So let me introduce you to another tool, right? This is specifically for packages. So Noah and his team, they built Kpkg, it's Kandji packages tool. And what it allows you to do is upload a package into Kandji. But we have the same kind of pattern. We need the Kpkg tool itself. We need a Kandji tenant, of course. We need the API tokens for Kandji. And optionally, you could have a token for Slack if you want to push notifications on changes into a Slack channel. And we need the metadata for the package. To show you what this looks like, I'm going to jump into Kandji again. And I'm going to add a new library item for a custom app. and just show you kind of the manual way to do it. So we'll call this Google Chrome. I'll install once per device, installer package. I'm going to go to my downloads folder and grab this package that I've already downloaded. It's going to take a while to upload on hotel Wi-Fi. But you can see, I can set the metadata here, like the name, installation method. I could put it in self-service, set a category for, probably apps is appropriate, right? And make it recommended. I just have to wait for this to finish validating before I can click save. Okay. So now I've got a custom app defined through the web interface this way. I'm going to just go back to the list here and show how that's done. But I could do something similar with a command line tool, Kpkg. So if I run a Kpkg, and just to show you being honest here, I'll reset my environment. And so I need to put in the URL for my instance, the API endpoint. I'm going to use, I'll use the keychain to store the token. And I've got to go grab it, right, because I don't have that memorized. Oops, I did that wrong. Okay, my bad. So my instance URL, I'm going to use the keychain. I'm going to store the Kandji token in there and paste it. I get prompted, so it can use my keychain. And I'll use a Slack token as well. And I'm going to grab that from my note. And again, password to store it in the keychain. So it's ready to go. Now I just use Kpkg with the package, and I have to provide the path to the package I want to upload. It's as simple as that. So it's going to do the same thing. It's going to grab that package file. It will find the associated metadata. I'll explain that in just a moment, and upload this into Kandji with the API. So in this example here, like, where is the metadata coming from? Well, we've done something fairly similar. If we take a look here in the Finder, find the right location window here. Okay, in Kandji packages, there's a config JSON that stores the defaults. So if I don't provide any information, these are the values it will use, category, and so on. You'll notice that there's two options, one for production and one for test. So if you want to set up a flow where you push a new version into test first, and then you can change it into a production group later, that's supported here. But it'll use these values if they're not defined. This package map JSON includes individual entries for specific apps. So if I want to override the defaults, I can do that by including the package name here in this JSON and providing, for instance, the name and the category and so on. Okay. So let's see if all this worked. If we refresh this list of custom apps, I'm going to filter it down again. Sure enough, we've got a new custom app in here from Kpkg. So one more example, Kappa. This is, I've forgotten what it stands for just now, but Kandji AutoPkg something automation, right? Something like that. I apologize to Noah for going blank on stage, but Kappa is another tool that works as an AutoPkg processor. And we need the same things. We need the Kappa tool itself. AutoPkg processors are written in Python, and they build a chain with your recipes. So you need Kappa, you need AutoPkg, of course, your Kandji instance, you need the API tokens, and you need metadata for the files that you're going to upload. So AutoPkg generates the PKG, but you're going to need the metadata to describe the name, the category, et cetera, that's going to show up in Kandji. So let's take a look at this one. I've got a folder here with the details. So again, just to make sure I'm being honest, right? I'm going to delete the I'm going to delete what I've done previously. And let's go into terminal. And I could type in this whole command, but I'm not going to. But you can see what's happening. So AutoPkg run. I'm going to use the verbose mode just so we can see the output. It's got the path to the AutoPkg recipe for Google Chrome. And then this last little bit here, the dash dash, is a post flag for post processor. And after this recipe runs, it's going to call Kappa. And Kappa is going to take care of picking up the PKG file that AutoPkg has created, and it's going to upload it into Kandji using the API. So we'll zoom out here. It's going to run the recipe, which will follow the steps of going out to Google and looking for the latest version and downloading that DMG. It takes the DMG and finds the app bundle inside, unpacks it, copies it, builds a package with that app in it, and then moves it to a location that it can use with a very specific naming convention. So all those steps are covered in this recipe. Right now, it's got the disk image, it's copied the app out, it's building the package so that it's finished. Downloading, those next steps move pretty quickly. Building the package takes a little bit, and then uploading, well, we'll see how long it takes with the hotel. While we're waiting for that, let's take a look at how this works. So I've got Code Runner here with the recipe open so we can take a look at how this is built. It uses this ID. The parent recipe here is written by someone else. It will download Google Chrome, the DMG file. It then uses this processor here, the app DMG versioner, to grab the version from the DMG. It will use another processor, this package root creator, to start building a package. There's another processor here called copier, which will take that package and move it to the that cache location with this naming convention. Okay, builds the package creator with the version and bundle ID, removes the DS store file. So this processor takes care of that, and we get to the end of the recipe. At this point, it hands it off to Kappa, which does the uploading portion of it. So let's check on our progress. Looks like it was built, looks good. So we'll take a look again at our Kandji instance and refresh the page. Custom apps 3, it's looking good already. Sure enough, now we have a new custom app provided by AutoPkg. So how did Kappa do this? Let's take a look at how this is set up. In Kappa, we have something similar. There's a config JSON that has the defaults, and if it doesn't have any overrides or any specific entries for that package, it will apply these default settings. If we look at this recipe map JSON, this is where the specific entries for Google Chrome, in this case, are stored. So the name that shows up in prod or testing and the category that's assigned to it. So you could use this method to define all those metadata settings that need to go with the package after it's built. Okay. Cool. So how do post processors work in AutoPkg. There's a couple ways to use them. So you could implement it with the recipe override. Just to be clear, you cannot put in like a post-processor entry in a recipe. But just like you saw, a recipe is a list of processors. And as AutoPkg runs through them, right, it hits each step in order. You can add Kappa as a processor, into the override at the end. And so that would be the last step in the recipe. The other way to do it is the way I just showed you. From the command line, you could use the post flag and specify the recipe for Kappa to run as post. And then a third option would be to use AutoPkg. And AutoPkg has some setting options to specify the post processor so that you could configure it so every time AutoPkg runs the recipes, it will always send every recipe to the Kappa post processor. Okay. So what were some of the considerations when we went through this process? So one is there is additional metadata that's required for your management tool. So I showed you Kandji as an example, but whatever tool you're using, there is going to be some metadata that you'll need to provide: the name, category, if it's in self-service, how it's being installed, what the enforcement looks like, et cetera. You'll have to figure out how to store that and where to store it and how you're going to manage it. For the GitHub example, it was important to me to store the metadata and the file together in the same place so that whoever's managing that repo would see both of them together. And so a very simple convention that I implemented there was the metadata has the exact same file name as the script file. It just has a different extension, right? So .sh for the script file, .json for the metadata. I found that, just an easy way to think about it. Now, there's the debate about convention or configuration or convention over configuration. There's a lot of value in using simple conventions like the one I just did. You could imagine a different implementation where you have a separate file that your action looks at every single time to figure out where the metadata is stored for that particular script. And now you've got a map that you need to maintain separately. But this simple convention was useful here, but there is some configuration that you still have to do, right? There are some things you can't just solve with convention. So at the end, I think the most pragmatic response is you have to use conventions where it makes sense and implement configuration where you need to. And the third item here is security. Managing the secrets is a big deal. A less sophisticated approach would be to just put the API token keys into the repository, but then they would be visible to anybody who has read access to that repository. So using secrets with GitHub, that's a good way to do it. For the local implementation, we could use environment variables. I chose to use the keychain in order to store that information. Those are things you really need to think about. If you're going to implement this kind of flow, where are you going to put the API tokens? How are you going to keep those safe so they don't get exposed unnecessarily? All right, if you want to learn more, we have a public GitHub repo for both of these projects, github.com/Kandji-Inc. And then there's one for Kappa, one for Kpackage. These are open source projects. We invite you to take a look, make pull requests, suggest improvements. Like I said, we've made some very deliberate choices about conventions that we use in order to streamline the process of using these tools. But there may be room for improvement. We would welcome collaborators into these projects. This is something that we want to do out in the open and invite the community to join us in making these tools really useful and making them really the best that we can. If you want to learn more about the Kandji API, api-docs.kandji.io. api.kandji.io will redirect there. And then lastly, we have an exciting product announcement that's coming up in a few weeks. I was really kind of disappointed I couldn't share it with you today, but our marketing team has put a lot of effort into a launch event. It is coming up June 5th, so not very long from now. If you'd like to learn more, just go to Kandji.io. There's that big blue bar across the top where you can click and register and get the URL to watch the stream live. And of course, it'll be available to watch offline after that. But we'd love for you to join us on June 5th and watch in real time. And I think you'll be very interested to see what we have. We're pretty excited about it. But thank you for your time. It's great to be with you again. Enjoy the rest of the show, and thanks again for listening.